Welcome to the Kick training video for eTPU Calibration Check. In this video, we will show how to verify and calibrate your eTPU unit. In this training video, you will learn how to verify your hardware and ensure you have everything you need to successfully complete the calibration or determine if your Kick eTPU must be sent in for repair, how to properly connect all of the hardware, and how to find, run, and use the eTPU utility. Before starting the calibration, please verify that all the correct hardware is available. For the eTPU calibration, you will need an eTPU. The eTPU is the control device that, among other functions, measures temperatures for your Kick automatic system. A calibration adapter. You can get this piece shown in the video from Kick. And the calibrator. In this video, the K-type simulator calibrator, model CL23A from Omega is used. You can purchase your own K-type temperature calibrator. After verifying all the hardware needed for the calibration, please make sure you can find the eTPU utility that we will use for this procedure. It is located inside your automatic system folder under the folder name Flash and Test eTPU. Open the eTPU utility by double-clicking the executable like shown in the video. Now that you have verified that all the proper hardware and software is available, we will show you an example of how to properly connect and set up the temperature calibrator. Please remember always to unplug the power from the eTPU, as shown in the video, before plugging or unplugging any cable. This will prevent damaging the unit. In the calibrator, you may have two channels. One channel may be an input to read or measure thermocouple temperature. The other should be an output to be used for simulating a K-type thermocouple output temperature for calibration. Please connect the adapter to the calibrator output as shown here. Next, connect the adapter to the odd port in the eTPU. The eTPU is now powered and connected to the calibrator. It's time for calibrating it using the eTPU utility provided by Kick. We have located previously the utility. Please double-click to open it again. Now click on the Get MAC and IP address button and select the proper network card. The correct IP address should be 10.254.254.1 like shown in the video. Now save and exit. Please note, for single systems, the eTPU TCP IP address is 10.254.254.128, but for dual lane systems, one of the eTPU IP addresses will end with .129 and the other with .130. To start the communication with the eTPU, please click on Start eTPU button. You will notice that the button will be grayed out. Some of the fields will be automatically populated, like the current serial number, and the buttons are now activated. To confirm this communication, you can also see the current probe temperature values under Kick probes. Now click on Check Calibration. A new window should pop up. Notice in the lower left corner, our timer countdown has started. We wait 20 minutes to allow the cold joint references of both units to stabilize to the same temperature. In the upper part of the window, you see the current offset value, gain, and the current live Kick probe TC readings. In the checkbox, you can choose between Celsius or Fahrenheit for units of measure. Note, if at any time the software sees that there is no longer a valid input, for example, the calibrator is turned off, you'll see a prompt. If you don't react to the prompt in 1 minute, the software will revert back to the first window and the timer countdown will stop. Our timer countdown has now reached 0. It means that both the calibrator and the eTPU components should be at room temperature, and we can start our calibration. We set our calibrator to the lower input by writing the same value as in the calibrator into the utility and check the status of the calibration. If it is green, it means that it passed, and we have met the required criteria. We can move on to the higher input and repeat the same process as before. Once our eTPU is inside calibration, we can choose to see the calibration report and save it as a PDF if needed. Let's see an example of an eTPU that is not within the tolerance. Once again, we set our calibrator to the lower input. We write the same value as in the calibrator into the utility, and we check the status of the calibration. As you can see, it's red. It means that the eTPU is out of calibration and you cannot move to the next step on calibrating to the higher input. Therefore, we should follow the instructions and click on Calibrate eTPU. Next, we click on Change Offset Value Automatically, and we accept new offset values. The change was successful. Now we can see what the change in the offset value does to our readings and that it puts us back in spec. Now that the lower limit is calibrated, it's time to move to the higher limit. As before, set your calibrator now to the higher limit and write the same value in the utility and check the status of the calibration. Once again, we are out of spec. Please follow the same steps as before. Click Calibrate eTPU, change gained value automatically, and accept new gained value. After the value was successfully changed, we can see that we are now back in spec. We follow the instructions, click on Calibrate eTPU button, and now it allows us to view the report and print it as a PDF. This concludes our video on how to check the calibration of your eTPU. After this training video, you should be able to understand and explain the different values in the eTPU utility and be able to verify and calibrate your eTPU for different scenarios. Please remember that to ensure the proper functionality and accuracy of your automatic system, it's important to verify annually the calibration of your eTPU. Thank you for watching and keep an eye out for the next training video.